Good afternoon. My name is Biggie Haraldson, and I'm going to throw a disclaimer out there first. I'm actually from Iceland, so if I throw some Icelandic words out you don't understand, then let me know. I'm actually in the aviation program director for Northland. Been there almost 2 years. Been in the aviation industry for roughly about 20 plus years. Last job I held was a director of maintenance, Part 119 brother, for a regional carrier. So all I know is aviation. I got into the Part 147 school for a reason, to bring what the industry is asking for, and also to be part of the unmanned aircraft maintenance training, which we're going to get into. What I'm going to do is go through our school just a little bit, who we are, where we're located, and so forth. And then Curtis Zoller, which is going to introduce himself right now, is going to go more into depth into the UAS industry and what we offer on the UAS side.
Hey folks, I'm Curtis Zoller. We'll try to keep as lively as possible. I know it's the end of the day, people are probably tired. Bottom line is it's going to be really off the cuff, so if you guys have any questions along the way, shoot, and we'll try to explain as best we can. But the one disclaimer that I'll throw out is that this is very new to everybody, and so as we go through these slides, we have some employment data, tech data, things of that nature, but bottom line is we're developing this program, and again, it's kind of the blueprint and hopefully the way ahead for the industry. But again, a lot of it is open to objective thinking per se. So again, if there's any questions or of course comments, let us know along the way.
Okay. All right, this picture is actually from our hangar in Thief River Falls, Minnesota. We do have quite a bit of aircraft, 36,000 square foot hangar. And this is actually our full-scale Global Hawk model, Block 10, that was donated to us from Northrop Grumman. This model actually was built to last for about a year for their promotion of the Global Hawk, but it was actually handed down to us 12 years later. So this model has been traveling all over the world, Singapore, Germany, Frankfurt, all over the place, and it actually does have the history. I counted in the shipping container. We actually take that apart. We could put into 3 40-foot shipping containers and put it up. And last place we put it up was actually in Grand Forks, North Dakota for the UAS Summit. And it actually, we counted on the wall 46 times. They've been putting it up and taking it down all over the world. So pretty neat. Who are we? It's kind of hard to see, but if you don't have your readers on, I'll read it for you. We're actually a community college up in state of Minnesota. We're part of the Minsk system, so we have 3 communities, one in East Grand Forks, which is right next door to Grand Forks, North Dakota, and also Thief River Falls for the main campus. Our aviation campus is located at the airport, at the regional airport in Thief River Falls. We have over 86,000 square foot facility. Included in that is 36,000 to 35,000 square foot hangar. And that is solely for the aviation program itself. State-of-the-art equipment. We do have over 20 aircraft. We just got a donation from the Detroit Pistons for a DC-9-32. That's their executive and players airplane. They've been transporting the players for years. Just got in about 3 weeks ago or so. It was about negative 40 degrees when the airplane came in, so that was actually pretty interesting. Large commercial airliners, we got 2 DC-9s, one in the heavy maintenance stand, and also a 727 outside, fully functional, along with a 727 on jacks and a hangar, where we demonstrate hydraulics. Helicopters, we just purchased a Bell 206 helicopter that should be fully operational here in a couple of months, and a full-scale Global Hawk unmanned aircraft. Northland Aerospace consists of 4 areas. First one is the crown jewel, the AMP program on site, and then the foundation for the UAS program is the AMP license. We're focusing on avionics, bringing onto the table AET program, which is the Aviation Electronics Technician. And then the last piece we're offering is the Imagery Analyst, which has nothing to do with maintenance. It's an additional piece to the UAS market. Aviation Maintenance Technology Program, it's a Part 147 program, so we're authorized by the FAA to teach the requirements for an A&P mechanic. We've been doing that for 52 years, for quite a long time. We probably trained about 99% of the Northwest generation of mechanics. Instructors are very experienced, been in the industry for about 20 plus years. And training, roughly the cookie cutter formula for us is about 2 hours in the lab, hands-on, for every hour in the classroom. All of the required FAA testing, prepware, and A&P testing for the FAA is on site. And all of our DMEs, or designated maintenance examiners by the FAA, are located on site. The program itself, the A&P program, is about 20 months, 4 semesters. Very low cost, and the reason it's low cost is that we're a state college, so we can't charge the money that other schools can charge. We offer the diploma, 88 credits, or the AAS program, which we add more classes to it for the management, 103 credits. And we also have articulation agreement with other schools. Example, UND, they give our students about 40 credits towards their bachelor's degree. Additional focus for our program now is avionics and also composites. The two things that the industry is asking for all the time: can you produce A&P mechanics with more background in avionics and also in composites? Big time. The airframe and power plant, for those of you who don't know what the airframe power plant is, it's actually issued by the FAA, and it allows you to certify aircraft in the airspace. You have to be 18 years or older, able to read, speak, and understand English, and also meet the requirements for the educational background. Who's hiring our A&P mechanics? Airlines, general aviation, aircraft manufacturers, aviation repair stations, crop spraying, which is a lot in our region, and also corporations, government, police, amusement parks. Amusement parks are hiring our A&P mechanics. It's a very good career to go into. A lot of the graduates that graduated from A&P school with me went to work for Walt Disney World. Amusement parks. The reason, a lot of these rides are sheet metal, composites, electronics, pneumatics, hydraulics, and so forth. So very sought after A&P mechanics. And also the windmill farms. Military contractors, and specifically for the UAS, which we're going to get in here in about 5 minutes. Job outlook for A&P mechanics. Boeing did a study based on aircraft sales, 2011 to 2030. Basically what they're saying is that the fleet is going to grow about 39,500 airplanes. That means they're going to be short about 650,000 mechanics worldwide. Roughly about 135,000 mechanics just in North America alone. So there's a huge need in this industry. Another thing for the job growth for A&P mechanics, ICAO, which is the International Civil Aviation Organization, is actually throwing these numbers out there. You can see the training capacity and what is required. So we're way far behind the curve for A&P mechanics. At Northland, we very proud for 100% job placement. The only people that do not get a job are the ones that do not take their A&P license or the oral and practical test, and also the ones that are further in education. We have more jobs for A&P mechanics than we can actually produce. Our main goal is to listen to the industry and produce the mechanics that they need, the type of requirements such as avionics and composites. We do have on-campus recruitments. We have companies coming in, give presentation to our students, anything from general aviation to airliners to manufacturers, even the FAA, anything that has to do with an A&P job, so they can actually see all the opportunities out there for them. We offer full-time employment, and also we're working internships with a lot of the companies. Basically what they're seeing is the need for mechanics is so big in the industry, we cannot produce enough A&P mechanics. What they do is they come on site, and they actually work with us and try to recruit the students from the beginning, work internships and so forth. Another program we're going to be focusing on is the AET program, Avionics. We're going to have A&P prerequisite for that. That is a line maintenance avionics course, so basically anything to splice wires and D-pin and pin cannon plugs and so forth. Focus on manned aircraft, this program in particular, and we're estimated to start in 2013. Roughly about 2 semesters, and we actually offer this program. This is from NCAT. AET is also a big part of our unmanned aerial system maintenance training program. Unmanned aerial systems maintenance training program, Curtis is going to take it from here.
All right, so basically, aside from the whole, I know you got the A&P side and the AT side, but we want to make sure you guys have a baseline understanding of where we're starting from, basically. The UAS maintenance training program is 100% based on the A&P as a prerequisite. So how we start our program, we actually just received a Department of Labor grant for $4.9 million. Idea basically targeted displaced workers and put people back to work. Okay, so anyway, to summarize, our first student body is actually going to graduate this spring. We've already got, once again, I mean, we've only got 4 students in the first iteration of the class. Idea keeping the numbers low for the concept of operations per se. And 2 disclaimers: 1, I talk fast; 2, I'm military. So if there's an acronym I throw out there, or a concept of operations, something like that, you guys need further clarification on, let me know. But bottom line is, like I said, first class is going to graduate here in the spring, and we started them up in the fall. We're actually going to be starting other iterations in the summer and the fall term, and continue the UAS and the AET training from this point forward year-round. The UAS maintenance training program, it's based on industry-specific requirements. So basically what we did is we went out to an organization called NCAT, which some of you may or may not be familiar with. It's a National Center for Aerospace Transportation Technologies. Again, I hope that if there's anybody from the FAA in here, I'm not trying to insult anyone, but bottom line is we all know that the FAA, it's not exactly a fast-moving organization. It takes a long time to get up to speed, keep up with technology. We basically went to work and interfaced with multiple facets of industry, so General Atomics, Northrop Grumman, Lockheed Martin, a lot of Boeing, a lot of the major manufacturers that are out there for both aerospace as a whole on the manned side, and also for the unmanned side. Also with the military, Marines, Navy, Air Force, Army, basically anybody that has a stake in the fight for the unmanned aircraft arena. We wanted to make sure we interfaced and that we got their voice as far as what they felt was necessary for this training program. We then took all that data together, put it back into NCAT, and basically had them help us generate a national standard, which is very similar to the same standard you can get on the AET side, or the Aviation Electronics Training Program. A lot of the UAS-specific training is also similar to the AET training, which is the reason why when you graduate from the UAS program, you'll actually get both. You get the AET certification and the UAS certification as you move through the program. Heavy on avionics, of course, navigation systems, EFIS, a lot of computer-based architecture. You'll get operating systems information and basically a general understanding of Microsoft Office Suite, Windows, Linux systems, things of that nature. Heavy in composites, primarily due to the fact that a lot of the UAS industry as a whole right now is manufactured by some kind of composite technology or composite manufacturing. And whether it be carbon fiber, fiberglass, things of that nature. And actually one of the resident experts that we have training on site is actually Tim Wright, right here in the center of the room here. Actually formerly worked with Cirrus Aircraft and now is working with us at Northland College, helping us train and develop that program as a whole. 30 credits, 2 semesters. And again, A&P is a prerequisite. And the idea is that the military already does a good job of training very specific, focused employees. But the problem with that is that when soldiers leave the military, generally speaking, they're going to have an absolute understanding of one area. So let's say hydraulics or electronics or things of that nature. But it's not very often that you run across a military person, unless they've got 25 years plus in, that's very well-rounded and has that background in all the different areas. Our basic goal is to develop that industry standard and that well-rounded technician to go out and be able to train and work with the Northrop Grumman, the Lockheed Martins, whoever might be looking for our employees, and have that general understanding of technology across the board, rather than that very specific focus that you probably would receive from the military. The other secondary goal here is, of course, we all know that at some point the FAA is going to integrate unmanned aerial systems into the national airspace. It's only a matter of time. You look at the numbers, you look at the cost effectiveness of operating them. Again, that's where we're headed. And our goal is to make sure that when that does take place, that there's some kind of a standard that we know that there's still going to be the same level that we currently ask for on the A&P side for our manned operators. Because again, we're all going to share the skies. We want to make sure that the aircraft are all sound and there's no issues up there. So again, we're developing it from the A&P, moving into the UAS and the AET certifications, and going forward from there.
Yeah, I just wanted to point out, go one back. Since the UAS maintenance training was actually funded by DOL, the 22 credits out of the 30 credits for the program today, while the grant is in place, are actually free. So whoever has an A&P license today can walk into our school and take the program and only pay 8 out of the 30 credits.
So again, kind of recap a little bit what I just talked about. Again, there's no regulatory body today that governs what is required for an unmanned aerial mechanic. And so the idea here is by using the NCAT certifications, that when these mechanics do enter into the workforce, they are working for different organizations like UPS or some kind of logistics support, which is where we're anticipating the first aircraft will actually be employed, that there is that certification, that standard that's already kind of a constant that's out there. Look at all the different organizations that are hiring our mechanics. Again, there's obviously a military presence. It's no secret to anyone today that predominantly the majority of UAS applications that are being employed today are for UAS or for military-specific applications. So overseas combat environment, training on the state side, or border patrol are kind of the primary contributors today for unmanned aerial systems activity. What we're anticipating over the next 5 years, which again the FAA currently has a directive for full integration in the airspace by 2015. And when that takes place, we're anticipating that we'll have precision agricultural types of applications, search and rescue applications, peace enforcement, DNR. There's already a lot of operations on different restricted airspace. For example, Camp Ripley, Minnesota, there's currently the DNR is using, Department of Natural Resources is using unmanned air systems to track wildlife on the reservation, and also to do different flood control and observations of forestry and things of that nature. So again, the applications are currently being used. They just aren't being used across on the entire national airspace to date. Again, Customs and Border Patrol is a huge one today. CBP has been using aircraft for almost 10 years now. There's a lot of operations going on out of Grand Forks Air Force Base and, of course, Fort Huachuca, Arizona, which are, my understanding, the two primary hubs for CBP. General outlook, these numbers are from AUVSI. A lot of growth in the industry. Again, the numbers speak for themselves. Biggie already covered a little bit ago about the demand or the prospective demand for A&P mechanics. This demand is only going to increase as the UAS field grows and the aerospace applications grow right alongside it. So we're anticipating that, regardless of how many players come to the table for training institutions, colleges, whoever it's going to be, we're not going to be able to keep up with that demand. So again, it's a very good industry to get into at the ground floor. And again, if you have any kind of business background, management background, especially a military background with some kind of UAS experience, or a strong A&P background and know how to spell UAS, again, any one of these combinations will get you a very sound career in the unmanned aircraft industry. We just had the bill signed into effect here on February 14, 2012, outlines the activity and the rollout for the UAS across the national airspace. The first, targeted activity is for law enforcement. They can actually get a COA or a certificate of authority basically to operate inside a specific area within 90 days today for any aircraft that's less than 40 pounds. And that's one of those scenarios that, again, now we're being limited by the number of subject matter experts we have in the industry rather than by the airspace restrictions. And again, this is the outlook that we're expecting to continue over the next 5 years as the industry grows.
I just want to add on, one of the bullet points is 6 UAS test sites within 6 months. The FAA is actually working the final draft to pick the test sites where they're going to be in the United States. So pending where these test sites are going to be, it's going to be a lot of research and development, increased job opportunities for the SMEs in this industry. And having A&P background and being able to spell UAS, like Curtis said, you know, is going to get you far away to get a job in these areas. The biggest players looking for test sites, we're looking at North Dakota, we're looking at New Mexico, Ohio, and so forth. There's a lot of states interested. Why they're interested in the test sites is because of the growth. In previous slides, up to $94 billion estimated growth in the revenue from UAS. So that's why it's very important to look at these 6 test sites where they're going to be announced coming up.
I'm assuming you guys don't want me just to read the slides to you. So again, the data's up there. If you guys have any questions about one of the bullets, give me a holler. But I guess the major takeaway from this is that as we look at unmanned aerial systems training and applications, it's not only applicable to the unmanned field. The only thing that's going to do for prospective students or people that want to come back for sustainment training is basically give them that next level of understanding for the program. So the A&P already trains a certain amount of avionics. It already trains probably 80% of the fundamentals that you need to be a qualified professional in the unmanned industry. All we're doing is taking that extra 20%, adding the computers, the radio theory, the satellite communications, GPS, all that state-of-the-art technology, and adding that into our training program, basically taking them to the next level. And again, my opinion is regardless of whether you're going to end up in UAS over the next 10 years or not, those are skills that you're going to need to work for anybody. Again, technology is changing so fast. The commercial airlines, the general aviation, you name it. Even, I look at one of these modern Cirrus aircraft that are rolling off the line today. For a lot of our A&P mechanics, a lot of that is gibberish per se. It's high-tech technology, things that they're not really comfortable working with. Our program is designed to take them to that next level and really give them that foundation or understanding of electronics, avionics, and computers as a whole. Looking at non-military applications, one of the number one things that I hear across industry when we start talking about unmanned aerial systems, they say, well, that's military only. Well, absolutely it is not military only. The bottom line is today across the country, there's already a lot of research and development being had, especially for weather research, disaster relief efforts, things of that nature, things that we can get by with really closing down airspace and restricting general aviation until we can really hash out or flesh out what that overall integration plan looks like. But that is a limiting factor. Today, inside restricted airspace or in different areas where areas of opportunity per se, where there is a disaster relief or some kind of a state of emergency that's been declared, unmanned aircraft have been employed across the country consistently over the last 5 years, and some would even say 10 years, with a dramatic amount of success. Looking at search and rescue, looking at again wildlife monitoring, simple things like real estate mapping, something that you wouldn't think of, but satellite time and having up-to-date mapping of especially urban environments is becoming increasingly more difficult every single day. You'd think it'd be exactly the opposite, but as congestion increases, the ability to really get inside and see some of those pictures that a lot of even architects and things like that would need to develop a solid plan or a way ahead. That's imagery that is not easily had these days. And again, these are all applications for UAS that can be done considerably cheaper than you could by enlisting a aircraft, a manned aircraft, or a helicopter or something like that to go out and conduct the same type of photography. Here's some of the success stories over the last couple of years. Again, we already talked a little bit about border surveillance. Arctic research, again, very unrestricted airspace obviously down there, so it's another area of opportunity to employ UAS. And you'll notice that a lot of the UAS applications today are in primarily remote areas. But again, as that integration plan rolls out, that won't be the case. And we've always said over and over again, it's only going to take one absolute success story to really pop the top off this thing, and that's really what we're waiting for. That first kid that's specifically rescued because an unmanned aircraft and an electronic search pattern could be used more effectively than looking out the side of an airplane, things of that nature. I mean, it's the applications out there are pretty much limitless. A big topic of conversation up in my neck of the woods is precision agriculture. I'm looking at crop mapping, identifying different areas where you can spray, different areas where, like we have a flood problem in North Dakota and Minnesota. So they actually use aircraft today to go out there and analyze the fields and use precision types of engineering to take care of some of the flood problems. Again, these are more applications that would be easily accomplished with unmanned aircraft. Search and rescue, already talked about. All right, so we talked about all the different unmanned side, and again, the imagery analyst, we figured it deserved an honorable mention, not necessarily because it's part of the maintenance training program, but because you kind of have to understand the application, understand the tool you're using. And the imagery analyst program is another element that we're ramping up at Northland College. But the idea here is basically all this data, all this imagery that's currently being collected by all the different unmanned systems across the world, it needs to be analyzed. And we talked to a lot of the higher upper officials at Northrop Grumman, and they're telling us flat out that the bottleneck that's being created by the unbelievable, unmanageable amounts of data that's being collected on a daily basis is continuing to mount. And so our goal also is to train those professionals to look at that imagery and identify what's important and what isn't, and basically give that to the decision makers to move forward with and use for whatever that application is, whether it be military, again, peace enforcement, agriculture, whatever the application is going to be. This is a basic flow chart at the college of different areas as you move through our programs. And again, the idea or the takeaway here is that the A&P certification is absolutely the baseline. I'm anticipating, and again, I'm told point blank that this is crazy talk from a lot of different professional perspectives, but I'm anticipating that as we move forward that the A&P certification today will go through a couple of dramatic changes. The bottom line is there's a lot of different types of training that, although it's important and it's a critical part of that foundation as far as an A&P mechanic and understanding where we come from, the analog instruments versus the digital instruments, things of that nature. Although that's very important, in order to keep up with the technology and to have those requirements to train those professionals to move out into industry without keeping them in school for 5+ years, is becoming a more and more of a challenge. So my anticipation is that curriculum will change dramatically over the next couple of years to anticipate more computers, more computer networking, more radio theory, things of that nature that will become more of an expectation or a precedence, and less of some of the more antiquated manufacturing techniques that predominantly aren't used as much today. That'll be more of the hobby side, and again, that critical foundation will be more based on current technology. So, for whatever that's worth, one guy's opinion. I'm drinking the Kool-Aid, though, again, being an unmanned guy myself, so kind of part of the bubble. Well, I missed a couple of arrows. The bottom line is looking at the industry as a whole. We already went from a major shift many years ago, which I'm sure some of you guys can remember. It's a little bit before my time in the workforce, but when we went from analog instruments to digital, and they kind of went away from that engineer in the cockpit. My anticipation is that actually that engineer is going to come back. I believe that the high dollar person that's going to be flying aircraft in the future, they're still going to be able to fly that aircraft. They're going to have that aerodynamic foundational understanding of how that aircraft works. But the big ticket guy in that aircraft will actually be the person that can troubleshoot those computers, troubleshoot those avionics, and really get that aircraft out of trouble rather than the literal stick and rudder guy that we see today. I really believe there's going to be another paradigm shift, and it's going to move back in that direction in the next 10 years. And again, I guess only time will tell. But again, I think that the day of the engineer and the technician is only starting to come back, and we haven't seen even the tip of the iceberg on that yet. So again, we'll see how that rolls out. At this point, I'll open up to any kind of questions. Again, I went through that really fast. If you guys have anything for me, please shoot. Okay, so he asked about the sensor packages for the aircraft. Are you talking about our aircraft at Northland, or are you referring to U.S. as a whole? Okay. Well, we've been working kind of hand in hand with University of North Dakota, NDSCS in Wapaton, North Dakota, and a couple other groups that are out there today on answering that exact question. Today, there's already been research and development on different types of radar, synthetic aperture radar specifically, LiDAR, obviously EO, IR, infrared, or electro-optical, which is like your standard photography and your movie camera. All these different types of payloads that are out there to put together literally one picture. We call it basically the multispectral image. If you look at satellite imagery today that they use for analyzing different types of vegetation patterns around the Earth, NASA takes a lot of that types of photography. There's actually a camera called AgCam on a satellite that UND currently employs. That sensor package is kind of it's a morph per se, or it has several different ways to analyze the picture, and that's kind of what I figure is the way ahead. When we look at small UAS, of course, we're limited by weight, so a lot of those are going to be probably IR and EO specific. And we start getting into some of the medium to large aircraft. For example, a Global Hawk aircraft, the synthetic aperture radar package that's on that system, it's pretty advanced, and you take a lot of different data at one time. So I guess, well, I don't see why not. I mean, a lot of these different sensor packages, they're not, the sensor package itself isn't necessarily classified per se. It's the applications thereof. Right, and like I said, I mean, it's going to be a stepping stone through technology no matter how we look at it. I mean, you look at, infrared, for example. The easy access to an infrared camera today is considerably different than what it was 10 years ago. I'm anticipating that same type of growth. When we talk about synthetic aperture radar, we talk about all these other types of payloads and sensor packages. And again, anticipating that growth or that rollout will be, very similar to a microchip. That's only limited today by the number that you want to produce and what the application is going to be. They look at, making multiple copies in order to create that. Again, IR and different types of sensor packages, same type of scenario. As there's more of a demand, again, I'm anticipating that will become more and more practical and less classified per se. So if the question today is it applicable, you're absolutely right. There's a lot of packages out there that we can't even train on. That's where we get into a lot of customized training for our clients specifically to offer that proprietary training. But again, that's obviously very specific. No, this training is specific to, again, the airframe and power plant license and everything that comes with that. We have a 3-stage avionics approach. So you have avionics intro, which is basically all the same stuff you get from any AAT program. Then we get into the command and control element, the ground control station, and then a data links course, which is specific to the communication theory, the language, the SATCOM, all that kind of stuff. And then we get into the advanced composites, repair and manufacturing techniques. I mean, those are really the elements that we're adding to this on top of the computer language. So again, it's more about understanding that foundation and that basic theory. So when you get out to industry and they put you through that on-the-job training or that OEM-specific training, that you'll have that foundation that's necessary to understand it. Well, if I was to summarize the patterns that we're seeing today, again, I already mentioned that today we have 10 students in the program. The primary reason is, for those of you that don't know, Northland College was on the verge of closing 3 years ago. We only had 7 students in the program. Today we have 70 and it's moving upward. Of those 70 students, this summer we already have 27 applicants from the A&P program that are going to go into the UAS program. So because the A&P certification is a prerequisite, that poses certain challenges. When you look at folks that have an A&P certification that aren't coming directly from our program, again, a lot of those folks are more seasoned per se. They have certain skeptical thinking as far as where technology is headed and things like that. And so it's a little bit harder to reach them as far as explaining what opportunities are really out there. The other major population that's really interested in is our military client base. But for the military, we still have to offer that equivalency or something like that, which means they still have to go through the A&P program to start. And again, that poses a whole other set of challenges. So I guess bottom line is we're in growth mode, and as we have these A&P certified students from our programs and from other programs that are of this computer age, the gaming age per se, we're anticipating a lot more interest. Today, we're just focused on that dislocated worker and and trying to explain some of the potential that's out there. So, again, I don't know if I answered your question, but we're definitely in growth mode.
Our youngest student is about straight from high school going into the A&P program, so 18, 19, 20 years old. Our oldest one is actually a retired captain. He used to fly for one of the major airlines out there. He's actually finished the A&P license, and now he's going through the UAS program.
We actually have a lot of students, once again, that are showing no interest in unmanned aircraft whatsoever. They're there specifically for the technology training. They want that advanced composites training. They want that higher education in the avionics piece, so that when they do go out to whether it be general aviation or wherever else, that they're better prepared for that 10-year forecast that they're looking at versus the 10-year forecast that maybe a seasoned mechanic that's already in place with Delta Airlines or one of these major MROs. So again, it's just understanding where the industry is headed.
I just want to summarize. It's not something we thought the industry is needing as far as UAS maintenance training. This is what the industry is asking for today. What they're asking for is they call it a mech tech. It's basically an A&P licensed mechanic, which they already hired to maintain the UAS, with avionics skills on top of that, computer geek knowledge, and then on top of that, some composite knowledge and understanding. That's what the industry is asking for. When we created the standard, we actually created the standard. There is no governing body for UAS maintenance technician. A&P is the FAA. So we actually sat down with NCAT, and we actually brought in a working group together, the whole entire industry, everybody that's maintaining and operating UAS, and we asked them, how does he or she have to look like as a technician? What are you looking for? And that's what we came up with. We created the standard based on the industry need. How it's going to look 5 years from now might be totally different, but this is what the industry is asking today. And what we're doing is we're doing exactly on the civilian side of the house how they're doing it on the military side of the house. So there's nothing new that we're doing. We're just creating and filling the gap what the industry is asking for. Today they're hiring the A&P mechanic. They're putting themselves in school for about 4 to 6 months, teaching the same thing we're doing. So we're actually taking the burden off the back and actually creating a mech tech so they can actually give them that 1 week in-dock class and specific on their equipment. Actually, it's a very good question. The reason, and we've been getting some kickback from the industry or more from the repair stations, why do you need an A&P license prior to going to the UAS maintenance? What we believe when it goes into the civilian airspace, these aircraft will have N registration number on them. That means when they have the N registration number on the equipment, that means you need to be an A&P certified by the FAA to maintain the aircraft, just like it is today. So why would we train not with that qualification when the industry is going to ask for that later on down the pipe? So that's what we did.
We're expecting them to treat this situation the same as you would if you're going to go for a higher rating as a pilot. So it's that added training that you need to have in order to operate specific specialty equipment. And we're anticipating this will be the exact same scenario where you'll still have that A&P foundation and whatever that looks like 5 years from now. And you have the AET or the UAS piece on top of that. And the other thing to take into mind too is that when we developed this NCAT standard, we had Federal Aviation Administration representation at the table. And they were helping guide the conversation and help us kind of align our objectives so that they kind of mirrored and they would match up. Obviously, what's best for us is if they were to adopt the standard in its entirety. But even if we get an 85% solution, that's still pretty good as far as anticipating what those needs would be tomorrow.
So there were twofold reason the FAA guy was in the workshop with us. Basically to make sure that the FAA is kind of following what the industry is asking for and what we're creating, and also making sure that they're not going totally different direction. And what they're actually working on right now with the FAA is that kind of follow the industry standards. That's the whole reason for the FAA to be in the workshop with us.
One of the other questions we field quite a bit is they ask flat out, if you have composites and avionics and the computer base and all other kind of stuff in this program, how are you making a good qualified training program on any of them? And the bottom line is that this training program, once again, is designed to create a well-rounded tech, basically to the troubleshooting level. It's not designed to create a depot level SATCOM repair or a depot level composites repair technician. It's designed to basically create a field service tech, much like the A&P is today, to go out into the field and create that repair, swap boxes if necessary, troubleshoot, be able to communicate with the OEMs to repair whatever that aircraft is or whatever the issue is today. If you walk on a UAS program today at Northrop Grumman, General Atomics, or Textron, working a Shadow aircraft, RQ-7B, RQ-4, or an MQ-9, they have a satellite specialist there, they have a composites guy there, they have an avionics guy there, they have an A&P, all these different specialty tasks. And our goal basically is to eliminate some of that need by having folks that are there that can basically serve as that overall technician across the board. So.
Okay. So, as a good question. The question was, how much is the industry paying today for technicians? Been in the airline industry for over 20 years. There's not much money to be made out there. But, basically coming out of an A&P school with no experience at all. General aviation, probably about $15 an hour. Regionals, probably $17 mark. The major airlines that are hiring technicians today, maybe $19, $20 an hour. Then, of course, plus premiums and so forth. The A&P mechanics we have actually placed with the UAS manufacturers and maintainers, they're actually paying them anywhere from $25 to $30 an hour. So going through the extra UAS training program, 2 semesters, they're adding, another $10 on top of their hourly pay, roughly about $20,000 a year. One of the manufacturers actually came for a visit to our school, talked to our students, and without even blinking, they said roughly, no experience, $70,000. If you go overseas, it's additional money on top of that. It's usually 2.8 times that. So that's what the industry is asking today.
The one thing you got to understand about the industry today is that if I want an RQ-4 Global Hawk mechanic, there's only one place I can get that experience. And that is a guy directly out of the Air Force that's been doing that job for the last 5 to 10 years. So a very specialized skill set. That said, that individual is a very high dollar individual. And as far as anticipating where our generalists will be placed in that, I'm anticipating it's still going to be higher than your standard A&P mechanic because they'll have those specialty skill sets that industry is calling for, but probably not as high as a person that has that specific platform experience. Now, if you look at some of these other types of organizations that are getting into the training overall, the general training for UAS, now on that side of the house, I'm anticipating our guys will place higher on the pay scale because now they're looking at a guy that can be multi-platform, more of a generalist, a guy that can move from a class 2 all the way up to a class 5, and they have that complete understanding. And once again, if you flip the switch per se, now a military guy is at a disadvantage because if you only have an RQ-7 Bravo experience, which is a 14-foot wingspan UAV, there's a lot of similar types of training considerations there, but it's not all inclusive. That guy's not going to be qualified to walk onto an MQ-9, 60 to 80-foot wingspan aircraft and know all the considerations of working with a larger aircraft. And so at that point now, that's going to be a little bit higher dollar item. Either way, I think to expect 55 to about 80,000 a year, that's not an unrealistic expectation for our graduates, especially if they have any experience whatsoever, either in the military or in the A&P realm.
The supply demand is going to weigh a lot going into the industry, just like the Boeing study and what the industry is going to be asking for just for A&P mechanics. We're so far in training what the industry needs for the next 20, 30 years. Now you're talking about additional 23,000 jobs on the UAS side, which is just addition to what the industry is asking for. So having the skill set is going to, I think the sky is going to be the limit here for the next 10, 15, 20 years, actually.